Okay, so let's go through example 9.3 from the OpenStax textbook. This is kind of a fun Star Trek problem. And so we have the Starship Enterprise. They tell us elsewhere in the book that the mass of the Enterprise is 2 times 10 to the 9 kilograms. And in this problem, the Starship is initially at rest, and then Captain Kirk says, put the Starship at 1/4 the speed of light, and so that's our final velocity. And if we assume it takes 60 seconds to do that, to go from not moving to moving 1/4 the speed of light, the question is, what was the average force on the Starship and on the people in the Starship in order to give them that large change in velocity? And so impulse is a nice way to solve this problem. Why is that? Because our equation for impulse relates force and how long that force is applied to, but it also is related to the change in the momentum of an object. Impulse is a vector equation, but let's just say we're talking about motion in the x direction, and therefore these are all x components of our momentum and of our force. Okay, and so it should be pretty easy here to calculate our change in momentum, because we know the initial velocity, we know the final velocity, and we know the mass. We know that it takes 60 seconds to make this change, so that should allow us to solve for the force on the Enterprise. Okay, in fact, the initial momentum is just 0 because the Enterprise is at rest initially. So this becomes equal to the average force times the time in which that force applied is equal to just our momentum of the Enterprise at time 2, the mass of the Enterprise times the velocity of the Enterprise at time 2. And so we can solve for the average force. The average force is equal to mass times velocity times how long that force was applied for. And so we can just plug in. The mass is 2 times 10 to the 9 kilograms. The velocity at this later time, our final time, is equal to 1/4 times the speed of light, which is 3 times 10 to the 8 meters per second. And finally, it tells us that the engines are on for 60 seconds. Okay, and so we can just plug into this equation, and we find that the average force is equal to 2.5 times 10 to the 15th newtons. Okay, so that's an absolutely huge force that would crush everything, crush every person. But that, if we do the math for the Starship Enterprise, that is what happens. So that's an absolutely huge force. Luckily, the Starship has, in the lore of Star Trek, has inertial dampers and things like that that will protect you. Right? So we can actually just use F equals ma to estimate that the acceleration of the Starship is therefore 1.25 times 10 to the 6 meters per second squared. And just so you know, the kind of maximum acceleration that a human can withstand is about what we call 10 Gs, right? 10 times 9.81, and so that's equal to 98 meters per second squared. So the maximum acceleration a human can handle is about 98 meters per second squared, right? One moment you're not moving, the next moment you're moving, a second later you're moving 98 meters per second. That's the maximum acceleration a person can handle. The acceleration here is a million times that, right? It's a huge amount of acceleration. And so luckily the Starship has inertial dampers.